I'm analyzing how feature importance is determined in a random forest model using the permutation importance method from the Sklearn library. This method is all about figuring out which features are most influential in predicting the outcome. We're looking at a specific scenario, predicting house prices. The permutation importance method gives us results. Square footage is highly important and number of bedrooms isn't. I need to figure out why there's this difference. I'm using a machine learning technique, permutation_importance from Sklearn, to understand which factors affect house prices the most. The results are interesting and I need to explain them. This suggests that even when I consider all other factors, the size of the house, square footage, is a really important predictor of price. This is a good explanation. Maybe the number of bedrooms and the square footage are very closely related. If that's true, the model might be using square footage to make predictions and ignoring the number of bedrooms, because they provide similar information. This could be why number of bedrooms importance seems low. Perhaps the model is learning the training data too well, including any noise or random variations. If the model is overfitting, it might not generalize well to new data and will give unreliable feature importances. This could lead to misleading results. The number of bedrooms is a category, 1 bedroom, 2 bedrooms, etc., not a continuous number like square footage. Permutation importance works best with numerical features. I might need to convert this categorical feature to a numerical one to get better results. This is another possible explanation for the low score. This is a multiple-choice question designed to test my understanding of interpreting the results of feature importance analysis in random forest models. Prepare the data for the model. This might involve things like transforming number of bedrooms into a numerical representation if it's initially categorical. I'd make sure all features are suitable for the random forest. This is a crucial step because the algorithm works best with numerical values. It's all about getting the data ready. I'd train a random forest model to predict house prices using my prepared features. Random forests are great because they are generally robust and handle various feature types well, but feature importance interpretation can still have subtleties. I'll use Sklearn's _permutation_importance function. It will shuffle the values in each feature one by one, seeing how that affects the model's accuracy. A big drop in accuracy after shuffling a feature means that feature is important to the model. It's like playing a game of hide and seek with the features and seeing how much the model misses them. I'd interpret the results to see which features the model thinks are most and least important for predicting house prices. That's what the question is all about. Figuring out why square footage seems far more important to the model than number of bedrooms. I'd get a list of features and their importance scores. These scores indicate how much each feature contributes to the model's ability to predict house prices. Higher score means more important to the model's predictive power. I'm using Sklearn's permutationimportance to figure out which features matter most in predicting house prices using a random forest model. My results are a bit strange. Square footage is super important, but number of bedrooms isn't. Let's figure out why. This is a likely reason. A strong correlation means square footage is a great predictor of house price, even when we account for other stuff. This is also possible if number of bedrooms and square footage are closely related. The model might mainly use square footage to predict house prices, making number of bedrooms look less important than it actually is. Overfitting could definitely be the culprit. If the model is too focused on the training data's quirks, it will give inaccurate feature importance scores. I agree. Permutationimportance usually works best with numbers. Categorical features like number of bedrooms might need some extra prep, like one-hot encoding, to work correctly. I'm analyzing how different features contribute to predicting house prices using a technique called permutation importance. We're looking at a random forest model, which is a popular machine learning model. I'll explain how I interpret the results. The core question is, why does square footage show up as a very important feature for predicting house prices, while number of bedrooms is deemed unimportant by the permutation importance method? I need to explore multiple reasons for this discrepancy. I use the permutation_importance function from the popular scikit-learn library in Python to evaluate the importance of different factors in a random forest model trained to predict house prices. The function essentially shuffles values of each feature and measures the resulting decrease in model accuracy. A large decrease signals high importance. This option suggests that square footage has a strong direct relationship with house price, even when we consider other factors. That's completely plausible and a likely reason why it scores high. Here, I'm considering the possibility that number of bedrooms and square footage are very strongly related. The model might be using square footage to predict price, hence, number of bedrooms may appear less important. This is a classic case of collinearity, two features effectively saying the same thing. Overfitting happens when the model learns the training data too well, including noise and random fluctuations, not just the actual patterns. If that's the case, then the importance scores aren't reliable. Permutation importance works best with numerical data. Number of bedrooms is categorical, 3 bedrooms, 4 bedrooms, etc. If it's not preprocessed correctly, e.g., using one-hot encoding, the results might be unreliable. This could explain the low importance score. I see the core question is about the discrepancy in feature importance between square footage and number of bedrooms in a house price prediction model. We're using scikit-learn's permutation_importance, a method that shuffles one feature's values at a time to see how much the model's accuracy drops. A bigger drop means that feature is more important. The goal is to understand why one is important and the other isn't, based on several factors. Let's dive into the possible reasons. This is a key point. If number of bedrooms and square footage are closely related, high correlation, the model might only need one to make good predictions. It might use square footage more, underestimating the true importance of number of bedrooms. Imagine a model learning that bigger houses, high square footage, often have more bedrooms. The model is relying heavily on the size information, making the bedroom count less useful. This option highlights the direct relationship. Even when we consider other factors, a larger house generally sells for a higher price. This explains why square footage has high importance. The model clearly sees a strong direct link between the feature and the outcome, house price. This explains the limitations of permutation_importance on categorical variables. Permutation importance works best with numerical data. If number of bedrooms is a category, e.g., 1, 2, 3 bedrooms, direct permutation might not reflect its real impact. Preprocessing it, like converting it to numerical representation, might increase its importance score in the analysis. Overfitting occurs when a model learns the training data too well and doesn't generalize to new data. In this case, overfitting would make the feature importances unreliable. If the model is just memorizing the training data, the importance scores become meaningless. It could falsely show square footage as very important and number of bedrooms as unimportant, even if the reverse was true for new data. I'm analyzing how important different features are in predicting house prices. Specifically, I'm using a technique called permutation importance, which is part of the scikit-learn library in Python. It helps me understand which factors have the biggest impact on my model's predictions. I'm looking at the results from my permutation importance analysis. One feature, square footage, has a high importance score. Another, number of bedrooms, has a low score. I need to figure out why there's such a difference. I used scikit-learn's permutation_importance to measure the relative importance of features in a model that predicts house prices. My results show that square footage is very important, while number of bedrooms is not. The high importance of square footage might be because it's strongly related to house prices even when I take other features into account. This is a possible explanation for the observed results. It's possible that number of bedrooms and square footage are closely related. If that's the case, the model might primarily rely on square footage to make predictions, downplaying the role of number of bedrooms. Maybe my model is overfitting the training data. That means it's learning the noise in the data instead of the true patterns, resulting in inaccurate importance scores. This could explain why number of bedrooms shows up as less important than it really is. It's also possible that number of bedrooms is treated as a categorical variable, like 1 bedroom, 2 bedrooms, etc. If so, the permutation_importance method might not work as well without some preparation, like changing categorical data into numerical data using one-hot encoding or other methods. I think several factors could be responsible for my results. It could be a combination of the strong correlation between square footage and house price, the possible collinearity between square footage and number of bedrooms, the possibility of overfitting, and the method used to handle categorical features. I'm excited to have considered all these factors in my analysis.